Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now, an inclined line is the one which happens to be inclined to both the horizontal plane as well as the vertical plane. Now, since this oblique line happens to be inclined to both the reference planes, neither the front view nor the top view projections of this line, they will be parallel to the XY reference line. So since this line, it is inclined to both the reference planes, so the projections of the oblique line on the horizontal plane as well as the vertical plane will reveal its apparent length, and we will not be able to obtain the true length of the line on either of these two planes. Now, since this oblique line, it is inclined to both the reference planes HP and VP, so this line will be having both of the traces, that is horizontal trace as well as the vertical trace, and these traces will be obtained through the projection lines A dash, B dash and AB in the front view and the top view over here. Now let us read out the statement. Now a line AB 70 millimeter long makes an inclination of 45 degree with respect to the vertical plane. That is, we have got the true length of a line which is A dash B2 dash, or it will be AB1. So this is equal to 70 millimeter. Now this true length of the line, it is inclined at an angle of 45 degree with respect to the vertical plane. So therefore we get the angle of inclination of the true length with VP, that is angle phi. It is equal to 45 degree. So while its front view, it is inclined at an angle of 55 degree with the horizontal plane. So we have got the angle of inclination of the front view projection of the line, that is A dash B dash. It is inclined at an angle of alpha is equal to 55 degree with respect to the horizontal plane. And besides this, we have been provided about the coordinates of the end A. So end A of the line happens to be 10 millimeter above the horizontal plane and 15 millimeter in front of the vertical plane. So this line lies in the first quadrant. So we are required to draw the projections of the line and find out its inclinations with the horizontal plane, because its inclination with the vertical plane, it is already available with us as 45 degree. And we are also required to locate the traces of the line AB. Now let us work out how do we evaluate the projections of this oblique line. So step number 1, we draw the XY reference line. Now we have been provided with the coordinate locations of the end A of the line. So end A of the line lies 10 millimeter above the horizontal plane and 15 millimeter in front of the vertical plane. So since end A of the line lies in the quadrant number 1, so the front view, that is 10 millimeter above HP, this will be drawn above the XY reference line, and the top view of the end A, that is point A, it will be lying 15 millimeter below the XY reference line, since end A lies 15 millimeter in front of the vertical plane. So here we have got A dash, it is lying 10 millimeter above the XY reference line, and point A top view projections, they have been plotted 15 millimeter below the XY reference line. Now we know that angle phi, that is the angle of inclination of the true length of the line in the plan, that is AB1, it is equal to 45 degree. So we have marked this angle phi 45 degree through this point A over here, right? So through this point A, we have measured the angle of inclination of the true length of the line, which happens to be 70 millimeter long. Now we are going to mark the true length of the line equal to 70 millimeter. So AB1 we have marked as 70 millimeter in the top view projection. So once we mark this point B1 over here at an angle of 45 degree with respect to the vertical plane. So this is the true length equal to 70 millimeter. So once we obtain this point B1, a horizontal locus line corresponding to the point B1 we are going to draw over here. Now having drawn this point B1, another information we have with us, that is the front view A dash B dash. So the front view projection A dash B dash, it is inclined with respect to the horizontal plane at an angle of alpha is equal to 55 degree. Now we have marked the angle alpha is equal to 55 degree, and we know the orientation of this edge A dash B dash in the front view. So this is the orientation onto which my front view projection A dash B dash has to be plotted. So once I obtain the projection orientation corresponding to the front view projection A dash B dash at an angle of 55 degree, now I will be making use of the simple fundamentals of the projections of the line. That is, whenever we have got the true length of the line available with us at an angle of angle phi with respect to the vertical plane, now through this true length second point, I will be dropping a perpendicular onto the elevation side in such a way that I will be obtaining the front view length which will be parallel to the horizontal plane in the elevation view. So this is the length of the front view which I am going to obtain in such a way that this front view projection, this should be parallel to the horizontal plane. Only then I will be able to obtain the true length of a line onto the horizontal plane, that is in the top view. Now I have already obtained the true length of this line AB in the top view. So this true length will be possible only when I have got this apparent length in elevation, that is A dash B dash parallel to the horizontal plane. So how I will be able to obtain this length of the front view projection parallel to the horizontal plane? This I will be able to obtain once I draw a perpendicular from the second point of the true line, that is point B1 over here. So once I draw a perpendicular projection from the second point of the true line onto the locus line corresponding to the point A dash over here, so then I will be able to locate the coordinate location of the point B1 dash onto this particular locus line. So this is the horizontal locus line corresponding to the point A dash in the front view. So onto this locus line, I need to draw a perpendicular from the point B1 such that I should be able to obtain this point B1 dash onto the locus line corresponding to the point A dash over here. Now wherever this vertical projector and this horizontal locus line they intersect, I will be able to obtain the point B1 dash. And again, the direction of marking this projector line I have marked over here. So I know that I have drawn a perpendicular from B1 onto point B1 dash over here, that is onto the locus horizontal locus line corresponding to the point A dash. Now I have been able to obtain the horizontal projection corresponding to this front view projection line A dash B dash over here. Now what I need to do, I know this origin point, I know the orientation of the front view projection over here. This is the orientation of the front view projection line, that is it is inclined at an angle of alpha is equal to 55 degree with respect to the horizontal plane. Now I have obtained this front view projection parallel to the horizontal plane such that if this projection was parallel, I was able to obtain the true length of this line in the top view. Now with A dash as my needle point, I'll open the compass equal to A dash B1 dash and draw an arc which will be intersecting with this orientation line corresponding to the elevation projection line A dash B dash over here. So wherever this arc, it is going to intersect this orientation line which has been marked at an angle of alpha is equal to 55 degree. So this point of intersection will be providing way with the location of the point B dash in the front view. So once I locate this point B dash, so my front view alongside the elevation orientation line at an angle of 55 degree with respect to horizontal plane has been obtained. So once I obtain this point B dash, I am going to join this dark over here. So A dash B dash has been obtained at an angle of 55 degree with respect to the horizontal plane. And once again over here, the direction of rotation of this arc has been marked over here. So this way, now the front view projections have been obtained, and having obtained the front view projections, I know that since A dash and A, they were lying in one vertical projection line, similarly points B dash and B, they will be also lying in the same vertical projection line. So here I have been successful in obtaining the projection corresponding to the point B in the front view, that is B dash. So once I obtain this point B dash, what I am going to do? I am going to draw a vertical perpendicular through this point B dash onto the horizontal locus line corresponding to the point B1 over here in the top view projection over here. Now, wherever this horizontal locus line projection corresponding to the point B1 and this vertical projection line through this point B1 dash, wherever these two projection lines they intersect with each other, I will be able to obtain the point B in the top view. So once I obtain this point B, I know that B dash and B, they are lying in the same vertical line. Now I can join the end A with end B over here. So the point A can be joined with point B. So this way I have been able to evaluate the top view projection of this particular line AB in the horizontal plane. And once I obtain this plan projection in the top view, that is AB line I am able to locate in the top view, I will be able to measure the angle of inclination of this top view projection line with respect to the vertical plane. Now we can observe true length of the line, it is bigger than the apparent length of the line, but the apparent angle of inclination beta, it is greater than the true angle of inclination phi over here. So the apparent angles, they will be bigger than the true angles, while the true length will be bigger than the apparent length of the line. Now having obtained the apparent length of the line projection in the top view AB, now I can evaluate the true length of the line in the front view also I can draw over here. So let me draw it. So please check this. Now using the method of rotation of line, I am going to mark A as my needle point of the compass. I'll open the compass is equal to the distance AB, and then I am going to mark an arc such that this AB projection line, this will become parallel to the vertical plane. The moment I rotate this AB projection line, that is top view projection line, with respect to the point A, so up to the locus line of point A, I need to rotate this particular point over here. So through this A point, I will be rotating this line AB in such a way that this plan projection line, that is the length of the plan projection, length of the top view projection. So this becomes parallel to the vertical plane. So the moment I rotate it, after the rotation, the point I obtain will be B2 over here. And once again, the direction of rotation has been appropriately marked into the construction over here. Now, having obtained this point B2, I know that this distance, whenever the length of the top view projection, so this is made parallel to the vertical plane. So the projection which will be obtained onto the vertical plane, that is in the front view projection, I am going to obtain the true length of a line over here. So this true length of a line I will be able to obtain in the front view projection. Now I have been able to obtain the apparent length projections in the plan which happen to be parallel to the vertical plane. Now having obtained this point B2, from B2 I will be dropping a perpendicular projection line up to the locus line corresponding to the point B dash over here. So this is once again the direction in which I am going to move. From B2, my vertical projector line is going to move in this direction till it intersects with the horizontal projector line through B dash over here. So this point will be B2 dash. The moment I obtain the second end of the true length in the elevation. Now I can join A dash with B2 dash over here. Now you see, I could have joined this A dash with B2 dash otherwise also, because I know that the true length happens to be 70 millimeter. But I am just trying to make sure that whatever principles of rotation of line we are using, after using the rotation of line principles, whatever length of this line, that is A dash B2 dash, we obtain, it should be equal to 70 millimeter. So the moment we are able to measure this length and find out that this length happens to be 70 millimeter, it means that whatever construction we have made out, so this construction is absolutely perfect or absolutely correct. So there is no need to validate by any other method. So this way, by rotation, we have obtained the true length of a line. Otherwise, what I could have done, I could have put my compass over needle over here. Open compass is equal to 70 millimeter. Mark the length AB2 dash over here 70. But then the verification would not have been possible. Now I can measure the angle of inclination of this true length with respect to the horizontal plane. And this angle is equal to theta. And once again we can check true length of the line in elevation. It is bigger than the apparent length of the line A dash B dash in the elevation. But the apparent angle of inclination of the apparent length in elevation alpha, it is greater than angle theta. So this way apparent angle is greater than the true angle, but true length is greater than the apparent length of the line. Now having obtained the orientations of the line as well as the projections with respect to HP and VP, now we need to evaluate the traces of the line. So in order to evaluate traces of the line, first of all we need to evaluate whether the projections A dash, B dash and AB, whether they are intersecting with the XY reference line. Answer is no. So if they are not intersecting with the XY reference line, so we need to carry out the extension of the elevation projection line, which is A dash, B dash, which we have done over here. Similarly, the extension of the AB projection line, that is top view projection line, will also be carried out such that the intersection of this extension should be made with the XY reference line. So let us start with this extension. So A dash, B dash, it does not intersect with the XY reference line. So I have extended this elevation projection line such that wherever it intersects the XY reference line, I obtain the point H dash over here. Similarly, I have got the plan projection line AB, that is the black line over here. Once I extend this line, I find that this line, this plan projection line, it has intersected with the XY reference line at this point, and name of this point will be point V over here. Now from point H dash and from point V, I will be drawing vertical projectors, so that, let us say this projector we are talking about. So whenever we obtain this point H dash, so from here I am going to draw a vertical projector and extend it till it intersects the extension of the plan projection line. So wherever this vertical projector intersects with the extension of the plan projection line, I will be able to obtain the point H. And once I measure this distance H dash H, so I will be able to obtain the horizontal trace of the line over here. So this measurement of the distance H dash H will provide me the horizontal trace of a line. Similarly, wherever my plan projection line, it was intersecting with the XY reference line, we had obtained the point V. So from point V, once again, I am going to draw a vertical projector line and extend it till it intersects the extension of the elevation projection line. So this is my extension of the elevation projection line. So this is my vertical projector, right? So once I obtain this intersection, this point has been marked as point V dash over here. So this vertical distance measurement V to V dash, so this distance will provide me the measurement corresponding to the vertical trace of a line. So this way we can evaluate horizontal trace as well as the vertical trace of a line into this oblique line problem over here. Now this is the complete discussion regarding the evaluation of the projections of the line, the true length of a line, and the orientations or the inclinations of the lines with respect to the horizontal plane as well as the vertical plane. We will be continuing with further discussion regarding few more cases of the oblique lines in the coming lectures. So this is all for today. Thank you very much. Thanks a lot.